On it is, well, because I've been on a pretty long streak of doing these problems, and yesterday I didn't get a chance to because I was heads down with some other stuff that I had to take care of. But yeah, today I'm back to make a habit out of, and I took a break, but no more. I am back in the game, and today I wanted to try a problem that I've seen quite a bit. It actually has a lot of it seems like it's a question that's asked a lot. It has a high frequency of. I think it has. I figured I'd try this out. Now, like when I try to, and this isn't one of my typical tree problems or whatnot. It's uh, actually kind of. I haven't done a problem like this yet. I think on one of these videos, but I wanted to just get it working, off the top of my head. And, I just wanted to kind of think about how I can approach this. So I'm not like going to really think about how to optimize this problem right away, but I think I can put together something that works, and it's clear enough to execute all the test cases successfully, right? And that's the initial goal, and then, as you get more familiar with these kinds of problems, you iterate and you get faster at it. So, but this is a bit of a tricky problem. It looks like, well, not really tricky, but there's some detail in here that's important to keep in mind. So, let's start. You are given an array of log files, I guess, like on a machine or something. Each log is a space-delimited string of words where the first word is the identifier. There are two types of logs: letter logs. All words except the identifier consist of lowercase English letters. Digit logs. All words except the identifier consist of digits. Okay, so there's two kinds of logs. Reorder these logs so that the letter logs come before all the digit logs. Okay, so we'll look at an example for this because this is already getting a little squirrely. The letter logs come before all the digit logs. The letter logs are sorted lexicographically by their contents. Okay, so the log has an identifier and then contents, and so the initial sort is by their contents. If their contents are the same, then sort them lexicographically by their identifiers. Okay, so lexicographically basically means alphabetically along the line of letters in the word. The digit logs maintain their relative ordering. Okay, so digit logs, however you find them, they don't change in there. They just get shifted pretty much to the end of your list. But they maintain the same order that they were in relative to each other. Okay, so that kind of makes sense. So the example will speak more. So here our input is a bunch of logs. So we have digit. So I guess this is a digit log because all the uh, parts of the log afterwards are digits, and this first part is identifier. So it looks like the identifier also, dig1, can be different from example to example. So in this case, digit logs have an identifier of A1. We simply know that so we can't tell what kind of log it is, whether just by the name of the identifier. We need to actually look at all the data and make sure whether it's a digit log or a non-digit log, letter log. Okay, and then the letter logs basically also have an identifier, unique identifier, and they have these guys here. Okay, they have all words that have no numbers in them. It looks like, I guess, right? So they're all alpha, not even maybe alphanumeric. So okay, so what we want to do is we want to sort these guys in the same manner that was said. We want to first sort by the letter logs, all come to the front, and they themselves have two sorting criteria. They're first sorted by whatever's in here, and then they're sorted by whatever is, if this is exactly the same as this, they're sorted by this guy, the lexicographical lettering here. So I guess at the very least, in a practical implementation of this log system, none of the digit logs would have, or any of the logs would have duplicate identifiers. Okay, so that's a mouthful. So you can see what happened here. All the letter logs are in the front, right? And they're sorted by, well, it looks like initially they're sorted by, yes, they sorted at first by content. So artcan comes before art0, comes before ownKit, dig by lexicographical ordering, and since the lexicographical ordering the contents is already handled, we don't care about what's happening in the um, identifier itself. Okay, so first thing I would do now when looking at this, I think I get what's going on. So like, and after kind of trying to look into the problem earlier, I'm pretty sure I know what's going on. So let's start with the fact that we need a result. Okay, equals new array list. So my first thing that I'm gonna say is that I think in an optimal solution, the logs that are the input string array would be able to be sorted in place. So we wouldn't need to create a new logs output. I mean, it's kind of hinted because the output is a string array rather than a list. But again, I want to just try to get it working logic-wise, and then we can refine it later on. So the next thing I want to do is create a digit log list. Again, probably a redundant identifier, but I would say, it kind of intuitively, without thinking about it too much, makes sense to me right now, because I want to sort the letter logs in one collection, or one part of the collection, in a different way that I want to set the digit log. So I imagine that I could just create a filter which filters through and adds the digit logs to the end. So the next thing is I want to do a priority queue. Okay, so I'm going to do this. I'm going to define my priority queue outside of my function. I'll call it let pq. And I'm going to call it equals new priority queue string. I'll tell you why I'm doing this in a second. I have this already in my mind. So this priority queue is going to sort the letters, okay? And why am I putting it as a priority queue? I could do it another way, but the algorithm that I have in mind in a streaming way, add to the different lists to be sorted in different manners, lends to using a priority queue, since it's looping through and adding stuff in log n time for each new element. So here I'm going to put a comparator here, custom comparator. So this is going to be essentially what I use my custom logic to do the string sorting. Otherwise, like, again, we don't want to do everything lexicographically, right? Like, we want to do something more intelligent. We want to sort by parts lexicographically in different ways, right? Parts of our input. So I'm going to use this typical compare method, which is an overridden version of the default compare function that this priority queue is inheriting from. So I'm doing this anonymous function here. So, okay, now what I'm going to do is set up the logic. So first we want to get the thing into parts, and I want to then get the identifiers, right? Because we're going to have to look at the identifiers and the contents independently. String a log equals a dot substring a length. Okay, so this is the a identifier. So what I'm doing now is separating out the actual contents, right? So the log itself, right? So the next thing I want to do is I want to split parts equals b dot split. Now I'm taking out the b portion. This is probably a little redundant. I could probably have some other method to do this, but I'm just leaving this like this for now. To be improved in the future. So ident equals parts 0. Okay, b ident equals parts 0, and then we want to get the log of b. So b log in the fashion that we did for a log, substring b ident, and just to that length ident So just to put it out there, is the substring function. I could have just taken the second part of. But here's the thing. A substring is just a quick way of doing this, right? I mean, I could have called this the substring before a certain value before the space, but I already split it. The substring is getting the rest of the contents because I don't want to re-add all the parts together that are separated by space. It's a little inconvenient. This in itself is probably not super efficient, but again, I want to get this right. So now I'm writing the comparison condition. A log that compare to B log. Okay. So what I'm saying here, if A log is not equal to B log, if the logs are different, then we're going to try to sort by logs. That's the first thing we're going to do. Else, and that's according to the description, else return a ident dot compare to B ident. So what this does is this second line checks out the identifiers, compares them, and sees which one is equal there, and which one is greater than the other, because that's like the last resort sorting that's going to happen here. Okay, so let's see. Let pq dot clear. Okay. I might take that out there, but all right. For now, this is my priority queue, and my reorder logs function is going to run the code there. Okay. So now let's get to the meat and potatoes. Okay. So the work is for. So this is going to look a little. I think this is going to be a little weird. No, I think it's going to be straightforward. Log. So I'm iterating through all the logs now. Now, I haven't written a function here, but I have a interest in writing this function. If digit is digit log /log, then, so if we have a digit log, then digit log list dot add log. Okay, and the reason I put this condition first is because the digit logs are small enough. You don't have to do any extra processing on them by adding them to the priority queue. But if we add these to the priority queue, then we're gonna have to do all the processing. So essentially, this is the first way is the quick way. Okay, so the digit log list, and then we have so now what we're doing is if it's a digit log, we add it to the digit log list. Otherwise, we add it to the let priority queue. So that means that at that point, the priority queue should be sorted by our rules that we've defined in our comparator. And for reference again, the comparator is up here. Okay, you see there's the rules that we talked about. I bet there's going to be a ton of compiler errors, but whatever. Okay. So, now what I want to do to the result array, which is the thing I'm going to add back, I want to, in order, in lexicographical order as defined by the priority queues comparator, I want to add those elements back to the list. So I'm pulling the priority queue, which is occurring pretty fast. And I want to just add those to the list. And then finally, I want to result.add all. So when I'm doing this, I'm adding to the result everything to the end of a little tired, sorry. Everything to the end of the result list. I'm adding all the digit logs because again, the digit logs are not sorted. Return result to array. Nice little Java 8 plus convenience nothing new string size. Okay. So I think that's it. So basically what I'm doing here is I'm just returning the result of the combined PQ, let PQ, and digit log list in that order. Let's run it. Of course, line 6 has a compiler error. Line 28. This is like half the battle. Oh, you know what? I did not even write my isDigitLog function. I am not done yet. Wow, I knew I was tired. It's been a long day. Had a lot going on. Boolean is digit log. So we have to actually write the thing that tells us whether it's a digit log or not. And so that shouldn't be too hard. That just involves looking at the individual pieces of the log content, right? Split. Okay, so I've split the pieces up for 0. I think this is right. I less than parts length and plus. Okay, good. And now that we have the main iteration, now we want to just check if every character is numeric. And so as soon as we find a non-numeric character, we drop, right? We return false because we know that that's not a numeric log, right? But at least by the definition that they provided us, return false. And then, if we manage to get through the entire iteration, return true. Okay. So, and then finally, mine is numeric function. Okay. Well, did I write this outside of the actual solution? Yeah, I probably did. Okay, I gotta put this guy in the actual solution class. Okay, so and okay, and then public boolean is numeric. And okay, because we're not treating this as functional. Int equals 0. I less than str.length. I plus plus. Okay. If digit I return false. So this is 2 levels of looping. This can probably be optimized with the other loop above somehow, but let's, for clarity's sake, I always say that when I'm trying to be lazy. For whatever the sake of I just said. So let's see, is digit log, this is a different error, but it alerted me to the lack of having a digit log to continue with. Logs. Log that split. Many more broken pieces of code, I'm sure. 56. Whoops. I'm on a crappy keyboard. Wrong answer. So why is that the case? Okay. Okay. Yes. I want to start at 1. I don't want to count the digit log. Okay. Accepted. Great. Great. Now let's try the whole shebang. And bam, accepted. Not very fast. Faster than 25.18%, lower 20th percentile, and less space than 41.94%. So, what did we do here? What could we do? So I could probably, again, like I said here, combine these two functions to test if the digit log is numeric. I have a numeric function here that goes through each of the pieces of that log, and then this goes through the log and looks at the parts, sends in the parts that is just the log. But usually what the case is this is a little bit like cleanup work to do at another time. The next thing I want to do, so this is the non-in place portion. This could all be done probably by string arrays in place. Okay. But whatever. For clarity, it is clear from here, I think, what's going on here in terms of adding the digit logs and the letter logs to the final log output, which is a different data structure, and then returning that data structure. So again, we could probably try to do this in place. So those are the first, like, at a high level, optimizations I can think of, and yeah, well, maybe for another time. So that's about it. If you like this video, like, subscribe, leave some comments or comment below in the section below. Leave some feedback. Let me know what I could do better, and also let me know what problems you want me to solve here, or you want me to go through and give you some feedback on how you could solve for your interviews or for anything else you're doing. With that being said, I'm gonna call it a night. So arrivederci, and see you tomorrow, most likely.